What about a combination? So we looked at the permutations, right? So 11.3 is, what if order doesn't matter? We're just picking some blanket, like 3 people out of 100, or, you know, something like that. Usually these are more of like a committee instead of president, vice president, and, or, the place that they're running in. So a combination of items occurs when the items are selected from a same group. No item is used more than once, and the order of the items makes no difference. So order doesn't matter. Okay, so these become tricky, and then this section we kind of bounce between them. Looking at these problems right here, which one is a probability or permutation, excuse me, which one's a combination? So we have to be able to distinguish between the two. So the last homework, you could just be like, they're all permutations. Now they're not. So 6 students are running for student governor, president, vice president, treasurer. The students with the greatest number of votes becomes whatever. Is that a permutation, combination if we're choosing president, vice president, treasurer? Were we specific? Yes. So order matters when we're specific. So this is a permutation. Okay, 6 people are on a board of supervisors for your neighborhood. A 3-person committee is needed to study the possibility of expanding the park. Does order matter? No, we're just picking, like, it's just picking people. We don't have a specific order of those people, so it's a combination. Baskin Robbins offers 31 flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many bowls are possible? Well, they're each a different flavor. Order matters. So it has to be a permutation. Yeah, because order matters. 3 different. Because you don't want, yeah, order matters. Gosh, that one might be easy to argue. Okay, how many ways can you select 6 DVDs from 200? Combination or permutation? Combination. I'm just picking some. So do you see how when it's detailed, it's a permutation, not detailed combination? And again, we could do a permutation with the counting principle by multiplying down. We cannot with combinations. You need to use the combination. Here is our formula. The only difference is it has this R factorial outside of the parenthesis in the bottom. So let's look at this example. A 3-person committee is needed to study the ways of improving public transportation. How many 3-person committees could be formed from 8 people? So it could be 8 combination 3, right? 8 total people. We are picking 3. So the formula would be 8 factorial, your total, over 3 factorial times 8 minus 3 factorial. So you have an extra number in there, which makes them less, makes there less combinations. There's more combinations when I care about the order in which people are placing or putting things or whatever it is. So this should end up being, that's 5 factorial. I can do 8 times 7 times 6 times 5 factorial over 3 factorial, 5 factorial, and those would cancel. And oh, I should do 3 times 2 times 1, right, for 3 factorial there. And the 3 and the 2 go into 6. So 8 times 7 is 56 is our final answer. Could you use a graphing calculator? A calculator? Sure. That's where we go into our C, right? So in Desmos, they have it too, where I can show it nice and pretty. So that was the one I did in the last lecture. So I go to function, And I see the C one, and this was 8, choose 3. So I'm going to go back 8, comma 3, and ta-da, 56. So some of them make you do the 8 first. Some are like that one. Either way. Okay. Problem 3. In poker, a person is dealt 5 cards from a 52 card deck. The order in which the 5 cards are received does not matter. How many different 5-card poker hands are possible? You gamblers, this is a great question for you. So if we look at this one, we have 52 total, right? And we are picking 5 cards. So 52, choose 5 with the C. So 52, choose 5. Okay. And I'm just going to put this in my calculator. It's a lot. 2,598,960. Yeah, that's a lot of combinations of cards. A lot. That's how many different hands you could be holding. And you know, no matter what order they're in, it doesn't matter. You're holding those 5. So if order mattered, the order in which you're given them mattered, that would even be way, way, way more, because it would have been a P instead of a C. Probably would have got too big for the calculator. Okay, so number 4, yeah, 4. In December 2011, the U.S. Senate considered 51 Democrats and 47 Republicans and 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? Okay, let's look this one out. Look this one out. That's weird. We have 2 things we have to look at. Democrats, right? And Republicans. Okay, so for the Democrats, how many total were there? 51. How many are we choosing? 3. So 51, choose 3. For Republican, we had 47, choose 2. So we're going to figure these 2 out separately and then times them together, because that's our counting principle. This many for this one, this many for this one, and times them together. So I get 20,825 for the first one, and I want to times it by the second one, 1,081. So this is going to be huge. 2, 2, 5, 1, 1, 8, 2, 5. Ugh. 22 million different ways to pick 3 Democrats and 2 Republicans. Holy moly. That's a lot of combinations. Problem 5, a zoo has 6 male bears, 7 female bears. 2 male bears and 3 female bears will be selected for an animal exhibit program with another zoo. How many 5-bear collections are possible? Okay, do we need to separate the male and females on this one? No, because they don't want like 5 males, or out of the 5, they don't want 2 males, 3 females or something like that. If they're being specific like they were in the last one, I want so many males and so many females in every single thing, right, that I'm picking. That is a difference. On this one, how many total bears are there? There's 13 bears. I'm just choosing 5 of the 13. And then I either put that in the calculator or I use the formula. Okay. Now, I put 6 random problems down here, and all of these are just random. It could be combination, permutation, or the counting principle. Okay, so problem 1, how many different 4-letter word passwords can be formed from these specific letters with no repetition of letters is allowed? So I'm picking 4 from how many? 1, 2, 3, 4, 5, 6, 7. So does order matter? It does on a password. So 7P4 is one way to do that. 7P4. So 7 math P4 is going to give me 840. Another way to do this one, this is how I would have thought of it. There are 7 ways for the first number, 6, 5, and 4. It's 4 things, right? And so 7 times 6 times 5 times 4 is 840. Okay, so either method works great. So counting principle or permutation. Okay, using 15 flavors of ice cream, how many cones with 3 different flavors can you create if it is only important that, if it is important to you which flavor goes on top, bottom, and middle? Okay, see how they were specific and they're like, this one, top, bottom, and middle matter to me. If you didn't matter, then it would be a combination. Because it matters, it's permutation or counting principle. So you can do 15, choose with the P, 3, which is 2,730. Or you could be like, there's 15 choices times 14 choices times 13 choices, which is still the same number. Either way that you thought that through. Okay, repeat the problem above, but assume you just don't care. I don't care. I just want these 3 yummy kinds of ice cream. I don't have repetitive because that's a different formula. I want just top, middle, bottom. So for that one, it becomes a combination. And there better be less choices. And I get 455. Excuse me. Is there a way to times this together and get your answer? No, combinations are formula, calculator. There isn't 2 ways to think through these ones. Okay, determine whether the following statement makes sense. I used the combination formula to determine the number of possible outcomes when ranking 5 politicians from the most admired to the least admired. If I'm ranking first, second, third, fourth, fifth, can I use a C? No, it's specific. I want you to be number 1, you to be number 2, you to be, it's totally a permutation. It matters. It matters to me whether I'm first place or fifth place. If I was doing a blatant just committee, just let these 5 people in, that's different. So this should be a permutation. Okay, write a word problem that can be solved by combination. So a word problem, and you have to times 2 things together. So I have one set of group over here where I'm choosing 3, one set of group over here where I'm choosing 2. There's 10 people here, 7 people here. Think of a word problem. So for me, I could think of like, I have 10 females and I have 7 males. I'm making a committee. I'd like 3 females and 2 males, please. That's the situation. You have to deal with females, males separately, times them. Okay. All right. In a group of 20, how long will it take each person to shake the hands of each of the other persons in the group, assuming that it takes 3 seconds for every handshake and only 2 people can shake hands at a time? Only 2 people can shake hands at a time. Okay, so we have 20 people total. And order matters, right? Because we're being specific, like shaking your hand versus this hand, that matters, and the order matters. So I'm going to do a permutation, choose 2, because only 2 people can do it at a time. Ooh, this is a hard one. 20 math, choose 2, and I got 380. So I'm choosing, I have 380, and then each of those is going to take, so there's 380 ways, and there's 3 seconds for each. Okay, 380 times 3 is going to give me 1,140 seconds. So what should I divide that by to get minutes? 60, right? Done this before. So that is equal to 19 minutes. It's going to take 19 minutes for every single person to shake hands. That problem's a little bit harder. I mean, yeah. All right, that's all I got for you. The biggest thing is trying to decide what you're doing. Let me know if you have any questions.